All right, as he said, I'm David Schuetz. I'm also known as Darth Null, and I have a lot of slides, so I'm going to talk very, very fast. So I apologize for that. Hopefully you can understand. All the slides are also going to be posted online with detailed notes on each slide, so you can go back and say, what the hell did he just say, and find it there. So why am I here? Basically, we've had customers that have, they need MDM. They're deploying iOS devices throughout their enterprise, and they need to put it out there, and they come to us with questions like, how secure is it? How does this work? We'd like to be able to answer those questions. That's kind of what we're paid for. But in order to answer it, we need to understand it. And unfortunately, the protocol, the way that MDM works with iOS devices was not openly published, still is not openly published. So we kind of figured out how it worked and decided that we'd share. So first, we'll talk a little bit about how configuration works on iOS devices. The end user, you sitting there with a little device in your hand, tippity-tapping on the screen, you can do basic things. You can set passcodes, you can set some restrictions. But all those settings that you can do as a user are, since they're created by the user, they can be removed by a user. Now, Apple added a way to password protect those settings so that you can set up everything up the way you like it and then lock it. So theoretically, an IT department could do that for every single device in their enterprise. But the problem is, once you lock that, you lock all the settings that are in that, underneath that umbrella. So you may be able to set a couple of things that corporate cares about, but then the user can't then go back and change certain settings that they may care about. So it's kind of an all or nothing sort of thing. So Apple also has the ability to push profiles out to devices that configure just the things that you care about. The nice thing about this is you can create a standard profile, install it on many devices. You know, the profiles are exactly the same. You don't have to worry about the intern doing one thing on one device and another thing on another device. They're all the same. You can also lock these with a password just like you can the other things, but the difference being that with this, the password only affects the changes that are pertinent to that profile. So if you push out a profile that says you have to have a complex password, and you can lock that, then all the other settings that the user might want to change, like disabling iTunes so their kid doesn't pick up the thing and buy something, you can still have those available to the user to do. And between the different profiles, you can push out as many profiles as you want. Between all the different profiles and the user settings that the user can put on directly, the system chooses the most restrictive set of settings. So if you've got one setting from the user, another setting from a profile, and a third setting from a different profile, the most restrictive setting amongst all those is what gets used on the device. So in order to create a profile, they have a program called the iPhone Configuration Utility. It's a free app from Apple. It's available on Windows and OS X. You use that to create the profiles. You can install them on the device. You can install certificates. In certain instances, you can install applications. Another nice thing about IPCU is there are many controls that are available through profiles that aren't available to the end user. So for example, on passwords, I don't really go into it. On passwords, you can set like a simple or a complex password as a user. Through the iPhone configuration utility, you can say it has to be 5 characters long and has to have at least one number, has to have at least one letter, et cetera, et cetera. You can put lots of additional controls on it through the profile that you can't do as a user. In iOS 5, they added some new things that are worth mentioning. One thing you can set through IPCU is requiring a password to be used for all iTunes purchases. So you can't make a purchase, then leave the app, and then come back to the App Store 2 minutes later and then buy something else without entering your password. You can turn off Siri. You can turn off backing up the device to the iCloud. You can turn off syncing documents to the iCloud or also the photo stream. You can force the device to reject an untrusted certificate so the user doesn't get a little pop-up saying, hey, do you trust this cheating, lying, dirty certificate? It doesn't show up. Some additional restrictions in mail, which are kind of nice in a corporate setting, especially not being able to move, restricting the ability for a user to move email from one account to another. So anyway, IPCU is fantastic. You can create these profiles, but you still have to get them on the device. You still have to hook it up with USB, drag the thing over, unplug it, hook it up to USB, drag it over. Pain in the neck. Obviously, you can't do that for 1,000 devices. So they also have a much more secure or a much more easy system using over-the-air updates using SCEP to establish secure communications, et cetera, et cetera. It's not easy to implement. I spent about 2 or 3 weeks trying to figure this out, and it's just a pain in the neck. And then after about 2 or 3 weeks of fighting with it, I saw the little note at the bottom that says, Apple says you should use a Microsoft or a Cisco SCEP server as part of the solution. I was like, oh, well, no wonder I couldn't make it work. The problem with this is that you still need to get the user to visit a link, whether you're using the secure OTA with the SCEP or just simply providing a profile on a web page that they just tap in mobile Safari. You still need the user to read the email to corporate-all and say, oh, I have to go here and tap this and download and install a profile. So that's why they have mobile device management. Mobile device management is basically the over-the-air delivery of profiles coupled with push notifications. Using this, the MDM server can send a profile directly to the device over the air remotely. Doesn't rely on the end user tapping anything. It just happens. In theory, you could update the entire enterprise, all of your iStuff, in minutes. It has the same configuration features as IPCU. You can even create the profiles in the configuration utility, export them, import them into most MDM servers, et cetera. But most of the commercial servers are going to have a full profile editor built in. Also, in addition to profiles, they give you some additional management control features, and we'll discuss all the features as we go on. So how exactly does all of this work? First, you have to enroll the device in MDM. When you do that, you're installing a profile that describes how the connection to the MDM server works, gives it all the information, and now it's managed. When you want to change something on the device, the MDM server sends a message through the push notification service, gets to the device says, oh, I've got to go talk to the server. It then reaches out to the server, says, you rang, and the server says, yes, please do this. And the iPod goes off and does this and sends back, okay, here, I did it, here's what you're getting back. It uses, as I said, push notifications. So let's talk a second about how the push notifications work. The device, when you power it up or whenever you switch networks, like if you go from 3G to Starbucks Wi-Fi and then back to 3G, whenever it fires up a new network connection like that, it reconnects back to Apple over a secure link. And as far as I've been able to ascertain, it's actually using a two-way certificate validation. The device has to see an Apple-issued certificate on the far side, and the far side has to see an Apple-issued certificate on the device. That cert is actually made when you first activate the device with iTunes. So it's actually signed by things that Apple trusts. So it's hard to break. I'm not going to say impossible. I just haven't really gone down too far. When it connects, the application talks to the remote server and says, hi, I'm here. I need to receive push notifications for this app. So for example, if your Twitter application fires up, it reaches, the device makes a connection to the push server. The first time you launch Twitter, it opens sends packets through that established connection. That connection remains open as long as you got the connectivity. Sends a note through that connection, says, hey, I'm Twitter, I need push notifications. And Apple sends back a 32-byte long token, says, okay, here's your address. Then the app goes back to the service provider, in this case, in this example, Twitter, says, hi, I want notifications for Schuetz, here's my token. And then notifications then go from Twitter to Apple and then down to the device using that token. And here's what a notification looks like. It's basically got some header data and the payload is a short message under 256 bytes, and it's ASCII sent in a JSON format. Again, the address on the message is the device token that the application got from Apple when connecting to the push service. The whole message has to be signed by the originator and then sent to Apple. So again, Twitter, or in this case, MDM server, creates the push message, signs it with a certificate that you got from Apple, sends that off to Apple. Apple then looks at the device token ID and then sends that to the right, down the right TCP connection to the right device. For MDM, it looks slightly differently. If you look in the bottom right there, for a regular connection, the payload is a high-level dictionary called APS, which has got multiple fields inside. In this case, it's just the alert message. For MDM, that APS field goes away and is replaced with just a single key MDM with a value, which is a long UUID-looking number. That number is the push magic number. That's established when the device first enrolls with MDM. So for MDM to send a notification, for the MDM server to send a notification to the iOS device, it has to have three things. It has to have the push magic that was given when it enrolled with the service. It obviously has to have the device token, because otherwise it can't get to the device. And also the device needs to know the user ID on the certificate that's being used to sign these messages. So it's a three-way authentication. If any one of those things doesn't match, then the MDM daemon on the device looks at it and just drops it on the floor. So, enrollment. Again, you need an enrollment profile that describes how the connectivity works between the device and the server. You can easily create these in IPCU, or obviously a commercial MDM product will do it all for you. But basically, the enrollment profile includes a URL for checking in, which is how it does the initial enrollment, and a URL for the overall service, where commands get sent and responses go through, and so on and so forth. Under iOS 5, this whole connection has to happen over a secure connection. Under iOS 4, it actually would work with just plain HTTP, which made my work a lot easier before. So again, you need to create this profile, you enter the URLs, you have to associate it with this push certificate, so you got to get the UID out of the subject field in the cert, that's they call it the topic, so that the device knows the signature that they're going to be looking for on the push messages. You also have to create an identity certificate that identifies the device, install that again in the profile. All those things get sent off, including, you also have to set the rights. So yes, I want this to be able to install applications, I want to be able to lock the device, I want to be able to wipe the device, etc. Once you've created that profile, you can install it the same as any other profile. You can install it through USB, you can install it over the air, you can tap on a link, etc. Most places, you'll have either an agent that comes with the MDM software that's kind of provides additional features beyond MDM, and that can do enrollment, or they'll basically, give you, when you give your device, give you instructions, surf to this page, enter this, they give a password and so on, and then that just pulls down the profile. All right, well, going faster than I thought. So the actual enrollment process, when it happens, you install the profile, then as soon as the device has the profile installed, it reaches out to the server and says, hi, I'm here. It sends an authenticate message. All the authenticate, actually I go into details what's in that message, but it goes to the server, says, I'm here. The server has a chance to say, yes, I know who you are. Great, I'm going to let you enroll. Or I don't know who you are. Go away. Or it could say, I don't care who you are. Go ahead and enroll. Once it gets a go ahead and enroll message, it then sends the device sends another message to the server, the token update, which sends all the important things, the push magic, the device token, et cetera, and that's where the actual enrollment happens. So here's what it looks like at a low level. Everything on MDM happens as just plain XML property lists. Property list is a standard format that Apple uses, and it's all sent over an HTTPS, or I wrote HTTP here, just over a put command directly to it. In this diagram, I've actually omitted some features there after the put, the content type, content length, encoding, all that kind of stuff obviously goes in there. But then it's just this XML file. In this case, the pertinent points are highlighted in red. You have a message type, authenticate. You have the topic, which is the UID off the push notification certificate. And then UDID is the unique device identifier. It's a long UUID looking string that uniquely identifies the device. And that's how the MDM server is going to track everything. So it knows it gives this command to that device, this command to the other device, et cetera. So the device will send this to the server, and the server will say yes or no. If the server just sends back a blank property list, apparently that's an OK message. I'm not sure, I don't remember what the exact proper message looks like. This is just what seems to work for me. Once the device receives the OK, it then connects back to that same port and sends, again, to check-in, another message. This time its message type is token update. Push magic is that UUID string that gets included in the MDM push message coming back. The token is the device token the device got from Apple when connecting to the push notification server. The topic, again, comes off the cert. It's what was provided in the profile. UDID is the device ID. And then unlock token is this long base64 encoded string. That's actually the key bag that you use to unlock the device when you need to remotely unlock it. So once all those things happen, the device is enrolled. So what can you do with MDM once you're actually joined into it? There were 14 specific commands. There's a few more now with iOS 5. And I kind of broke them up into 3 categories. Under configuration, you can install and remove configuration profiles. Those are the things that actually set things on it. It can turn off your app store. You can set an email account. You can set up a VPN, calendar accounts, things like that. Those are all configuration settings that can be pushed out to the device. You can also install and remove provisioning profiles. A provisioning profile is something you use when you're developing in-house applications. It's basically a way to sign the app with your developer ID such that other devices can then run your app even though it's not coming through the Apple Store. That's for custom enterprise application development. You can get status from the device. You can get information about it like the Bluetooth address, the memory level, the patch revision, what version of the operating system is it running, what's the battery level, I think is something that got added in 5, things like that. Security info gives just a few basic security bits, like whether the passcode is compliant with policy. Restrictions lists all the things that are turned off. So you can say, hey, what are your restrictions? It'll say the App Store is turned off, YouTube is turned off. Excuse me. You can also list the applications that are on the device or the certificates that are on it or the profiles, provisioning profiles. And then finally, under control, there's 3 simple commands. You can tell the device lock, and it locks the device. You can tell the device clear the passcode, and it unlocks the device, and the passcode is gone, so now the user has to enter a new passcode. And you can tell it to erase the device, which completely wipes it out. In iOS 5, they added some neat features. You can install or remove applications, 2 different commands, and if you try and install an application that's already existed, it will update it. So it actually, the little pop-up doesn't say install, it says it's about to be updated instead. You can also apply certain configuration settings, which, as far as I can tell, only lets you change 2 things, device roaming and voice roaming. I've seen hints that there's some other things in there that you can change, like wallpaper seems like something that's in there. I'm not quite sure why, but I haven't figured out how to make any of that work. There's also a way to apply redemption codes. I haven't figured out that either. It's for, I believe it's for the volume purchase program. So you can actually create, if you're a member of the volume purchase program, you actually buy, in bulk 100 licenses for an application for Angry Birds, and you put it on the server, and then you want just basically push out Angry Birds to a box, and instead of the users getting this thing, you have to install this from the iTunes store, you just get, it pushes out the redemption code with it, and you get it for free. A new status command, you can list the applications that are in it that are managed. A managed application in this context is an app that was installed by MDM. So remember before I said you could remove applications, you can only remove those applications which were installed by MDM. And that's a common theme throughout the way that MDM works. The concept there being that corporate has control only over those things that corporate imposes. So if you install a profile yourself, the MDM server can see that profile, they can see a little bit of information about it, but they can't remove it, they can't disable it, they can't do anything. They just know that it's there. The same thing for applications. So list managed applications just shows the apps that were installed and controlled by MDM. And then finally, there's the checkout command. An interesting feature about MDM is that the user can always remove a device from corporate control. Anytime they want to, they can just say, yeah, I'm done with this. I don't care about policy. I'm just taking you out. And it used to be that when that happened, it just happened, and nobody was notified, and the only way that your corporate overlords would ever know that you've taken your device out of MDM control would be that, hey, we haven't had an update from that machine in a long time. Why doesn't it show up on our list? Now it actually, when you try to remove, it'll send a message to the server saying, I'm going by, server can't stop you, but at least it knows. So here's how the commands flow. Again, when your device is powered up, it connects to the Apple push notification server. And then anytime that a command is being sent from the MDM server to the device, there's basically 4 connections that get the data goes over. It goes from the server to Apple, goes from Apple down to the device, then the device reaches out to the server, says, give me a command, and it gets the command sent back. And then once the command is done, the device opens a new connection back to the server and saying, okay, I did that, here's the response. Why is that not going? So here's what the initial response looks like. So back here where I say the device talks to the server and gets a command, this is what the device says to the server in order to get that command. It's just a very simple message that says status idle. And again, it's identifying itself by the unique device identifier. That way the server can say, okay, here's iPod such and so, you need to do this, and then it responds with a command. And here's what it sends back. In this case, we've got a clear passcode command that's being sent. Again, it's just an Apple property list, the top level dictionary called command, which has subfields inside it, request type, clear passcode. So the command in this case is clear passcode. This one obviously has an optional parameter called unlock token, and the value of that is the long binary string, which is the key bag which will unlock the device. There's another top level key called command UUID. Turns out that field is mandatory, but the content is optional. So if it's there, it can be empty if you want to. The whole point of this is so that the responses that come back from the device can be correlated with the commands that went out. So if you send out 5 commands and you get back 1 response, but the first 4 were missed, you know that the response you just got pertains to the last command and not the first 4. Otherwise, because it's an asynchronous protocol, it wouldn't know necessarily what was just acknowledged. So most responses are pretty simple. They'll say status acknowledged. They have the command UUID again, which is used to match up the responses and the commands. If it's not acknowledged, there'll likely be an error message in here, and there's lots of different kind of error messages the device can deliver. The query commands obviously will have a lot more information. So if you query it for device information, you get something like this. And I've gone out of XML format into JSON because it formats a lot better on the screen. But you can see here you've got available device capacity, which is listed out to some ridiculous number of significant figures. I don't know why. Build version, what else is in here? Is it roaming? The model number, firmware revision, OS revision, all that kind of stuff is in there. There used to be a field for jailbroken, but I've never quite figured out how that worked because I wasn't playing with this until after that feature went away. So believe it or not, we now actually know enough to create our own MDM server. So I did. Originally it was 300 lines of Python back last summer. Now it's grown to a little bit under 500 lines of Python. Just using standard libraries, web.py, Apple push notification wrapper I found off on the network somewhere. OpenSSL, the command line I used to create certificates for the server, for the CA, etc. It's basically just a really simple command and response console. You send a command, you look at the response, see what comes back. Very rough. It implements, shouldn't say all because obviously I've had at least a couple I haven't figured out yet. Implements most of the commands, doesn't necessarily give all the proper responses or respond to the responses. So if an error comes back, it doesn't do anything. It just says, oh yeah, I got an error. I don't care. Certainly there's no guarantees. This is not something you use in production, but it's a good starting point for experimentation, and it, along with my slides, et cetera, will be available online. So, Jesus Christ. Okay, does somebody have a question? No? Excellent. I need to change my pants. Oh, there is a question. Okay. Probably not much. They'll need a push notification certificate from Apple, which you can get if with Lion server or with a commercial MDM server. But beyond that, I'm not really sure there is much to stop them. So, all right, so let's see. Is my iPad still connecting? Hey, and speaking of jailbroken, obviously, since you can see my iPad on the screen, it's jailbroken, which makes it a lot easier for you to see what I'm doing. So we'll start up a server here, and let's come back over here. So you'll see some stuff come down in this window in the bottom left. I'm not expecting you necessarily to be able to read it, but you'll at least be able to see it as it scrolls by. And as interesting things happen, I'll read them to you. So we'll start up this, and let's see. Okay, so now I'm talking to my server. Up here in the corner, it says tap here to install the CA. Because this is iOS 5, I have to use a secured connection because I'm not going to buy an actual cert. I had to use a self-signed cert, which means I have to install a CA for it. And install now. Oh, it says trusted because it's already installed. Okay, so now that's installed. And actually, just to prove that I'm really doing this live, let's make sure that my other profile's gone. And it's not. Let's remove the old MDM. I was supposed to do this before. Oh, look, device leaving MDM. See, I told you I'd call out neat things. That's the checkout command. It worked. Okay, so we'll pretend this has never been enrolled. And again, one way you can do this is you can basically send out the email to everybody in the corporation saying, hey, you've got to go to this web page and do this stuff to tap in. Maybe you'll get a user ID and password. In this case, it just immediately downloads the profile, says, I want to enroll. You say yes. Warning, unsigned profile, it will change settings in your iPad, allow the administrator to remotely manage your iPad, may collect personal data, add, remove accounts and restrictions, blah, blah, blah. Yeah, well, they told me to do this. It's their iPad. I have to do this. I don't like it, but I'm just going to do it. Okay. So now it's enrolled. And I'm going to come over here, and let's see. So if I select the command device lock and hit send, that should then lock. Maybe. Please lock. Wait a second, it's not going out. There it enrolled. I did this morning and it worked just fine. No, it's enrolled. Uh, Now I'm annoyed. Am I getting out to the internet? I'm getting out there. Am I getting out here? Oh, I was in Safari. That's getting out. Well, shoot. I know everybody says this worked before, but honestly, this has worked every time I've tried this before. It worked at Black Hat. What the hell is going on? It's all encrypted. Wireshark's not going to show you too much more than traffic. All right, let's remove it just to be sure. We'll try it again. If this still doesn't work, I have a backup. I have a backup plan. It wasn't encrypted under iOS 4. Or it didn't have to be. You could be, but it didn't have to be. Let's remove all these things. See, it's talking to it. It knows it's there. It's just not getting the push notification. Which, I wonder if no, because again, I tried it this morning. I was going to say maybe push notifications aren't coming through the Shmoo network, but like I said, I ran it and locked it. So we'll try again. Install. Yeah, we're done. And of course, everything that I'm doing doesn't make any sense to me. I'm exercising voodoo, which I don't like. Did you close all the windows and open them up again? Okay. And you know what? Let's just do that just because. The push notification is not going through. Okay, I will cheat. I was going to show you this cheat anyway as part of a later thing, but I wanted to hold off. Let's see. var mobile library configuration prof CP MDM outstanding utilities. I'm going to force it to poll by adding a file in the right folder. The MDM daemon should see that file show up and say, oh, there's something left over that I didn't do before, and it'll immediately poll. I hope, dear God. All right, okay. We're going to pretend that push notification is working and just do it that way. Nice to have a backup plan. Okay, so that's one thing you can do. You can lock a device. Woohoo, there's an awful lot of work to lock a device. You can install profiles. So let's set up an install profile here. This profile should send a bunch of restrictions to the device. It's going to say you can't use the iTunes Store, you can't use Safari, you can't use YouTube. And watch, this one's going to work. Of course not. Yeah, push notification is not going through. That's annoying. We'll do that again. Bottom left, you see idle status, install profile acknowledged, and you should see a whole bunch of things disappear. Ah, right off the bottom, they all disappeared. If I say remove profile, they should all come back. Let's pretend to be Apple again. And there, oh, it only showed up on the bottom, but it's also App Store is here, iTunes is there. For some reason, when they come back, they don't always come back to the shelf. I can install applications. I can look at different settings. Where's my device info? We'll send that real quick. And acknowledged. So it sent the device information command. It was acknowledged. And if I come back to this window, I say refresh, and you see that's the response that it got back from the server. Current settings, look, it's now on iOS version 5.0.1. I can do that because of that whole, what was it called, Absinthe that came out. Although actually this isn't Absinthe because I'm actually on an iPad 1. So those are some of the things you can do with MDM. Again, there's a lot of other stuff up here that I'm not going to run through because I just killed a lot of time fighting with push notifications. So we'll come back here. What are some limitations? The user can terminate the MDM relationship. I mentioned that before. Anytime they want, they can just say, yeah, I'm done with this corporate man, I'm done, we're going to get rid of this. But whatever the MDM installed, all those profiles, the certificates you need to log onto the corporate VPN, whatever, those all get removed as well. Also, any applications that were installed, when you install an app, you can set two different flags. One of the flags says remove when unenrolling. So if that's set on an application that's been installed, when somebody checks out, it immediately deletes that app and all the data. So if you've got good pushed out, so people got corporate email in this little nice tight little container, as soon as they log out of MDM, it will remove that app and all the data. So you can force at least some of the protected corporate data to go away. MDM also does not address the commingling of data. So your information and your corporate information is still resident on the same device. MDM does nothing to protect how the data can move from one app to another. It doesn't do anything like that. To do something like that, you really have to go with a multi-user model, which the iPad doesn't support. Remember, MDM stands for device management, not data management, at least not yet. Can't detect a jailbreak. As I mentioned earlier, there was an earlier version of, the first versions of iOS MDM systems could detect a jailbreak. You could actually include in your device information, is jailbroken, and it would say yes or no. They removed that. I haven't figured out how it worked. I found some interesting strings in some of the old binaries, but I couldn't really make heads or tails of it. One of the reasons I think they got rid of it is it's just not that reliable. There's a bunch of little breadcrumbs you can look for. Is Cydia installed? Is Bash installed? Can I run unsigned code? But a lot of those tests just aren't that reliable, and it's a cat and mouse game. Apple's even found that out with the iBooks app where they install jailbreak detection, and then people work around it 3 days later in Cydia. So, and again, you also need the push notification certificate to make it work. Used to be you actually had to buy a enterprise developers program membership to get that cert to then go and use the MDM system that you've paid a whole lot of money for. Now it comes bundled with the MDM. Essentially, you create a certificate signing request, you go to the MDM vendor, they sign it, then you pass it back to Apple, and so on and so forth. I still think there's a lot of things in MDM that it could do that it doesn't. You cannot change the passcode. You can erase it, but you can't change it. I've seen indications that there might actually be a way to do that, but there's no way, there's nothing there yet. There's some things that would be nice to be able to disable, but you can't. It'd be nice if you could disable the microphone, because the mic is actually very sensitive. I actually took an iPad 2, started voice recorder going, locked the screen, closed the cover, sat it on my desk, and it recorded in intelligible quality a phone conversation on a speakerphone that was happening 20 feet away through a door and around a cube. So I was very impressed with that microphone. You can't turn it off. And in a corporate setting where somebody could just walk into a meeting, plunk it down on the table, and record the entire meeting and nobody would ever know, I don't like that. There are some basic settings the user can do that are not available in MDM. The user can turn off the picture frame, which is when you've got the device locked, you can hit a little button and see pictures from the album. Well, if you've got a picture of your latest gee-whiz, oh my God, super top secret prototype on your device, and somebody picks up a locked device and hits the picture frame button, they can just scroll through your pictures until they see that. Cannot turn that off at a corporate level. You have to trust the users to disable that. There's also a way the users can disable the creation of accounts. So you can say, okay, here's my email account, don't let the users create anything more. You can do that at the device level, just not at the MDM level. And MDM doesn't provide any kind of geolocation features. Those, like Find My iPhone uses some different kind of system to handle all that. Are there any interesting bugs? I found a couple. When you enter an invalid passcode, after you enter the 3 or 4 times in a row, it's fine. You just get an immediate try again, try again, try again. Oh, okay, now it's disabled for a minute. Oh, now it's disabled for 15 minutes. Now it's disabled for an hour. It gets progressively longer. If you are at the point where it's a 15-minute delay or an hour delay and it's locked, and you say, okay, I obviously don't remember what my passcode is, you call up your help desk, you say, hi, I screwed myself up, I can't get in, please clear my passcode. They send the clear passcode command and say, okay, it's done, it's unlocked. And you look at it and say, no, it's not, because it's got to finish out that delay first, which I don't quite understand why. I call that a bug. So it's got to wait for that whole delay to end, and then you can unlock it. Well, you can open it because the passcode's been cleared. Also, that count of the failures isn't cleared when the clear passcode command is sent. So again, you call up the help desk, they clear your device, your passcode for you, you log in. As soon as you open it up, it pops up a little panel that says, hey, passcode policy says you have to have a passcode, so you're a good guy, and you set the passcode, and immediately you lock it, so you can make sure you did it right, and you unlock it. If you fat finger it right then, the failure count is still in place from before, and now you've got another hour delay. So if you do something like that, be very careful when you re-unlock it. And that can go for days. If you lock it and then 3 days later you come back and unlock it and fat finger it and that delay count is still intact, you're locked out for an hour again. Here's another neat one. If you have a simple passcode, just the 4-digit number, and you keep fat fingering it and you call up and they say clear my passcode, and that passcode panel is still up while they send the clear passcode command, If you then hit cancel, you get this screen and there's no passcode panel, nothing at all. The device is completely locked, you have to turn it off. It's just kind of a funny bug. What's interesting is if, while that panel is up, you punch in 4 random numbers, it goes through just fine. So, I don't know. So are there security concerns? I mean, those are interesting bugs, usability annoyances. There's no command authentication. There's a way to say I've got to sign things, but I haven't found that that was directly enforced. For SSL, it appears to work with any cert that has a trusted root. So man in the middle is very likely very possible. And the configuration itself is also on the file system. The whole MDM enrollment profile is not protected in any way, and I'll describe why that's an issue in a moment. So what are some possible attacks? Very difficult, as I said, to forge the push notifications, so you got to do MDM. If you're actually MDM, you have to do man in the middle. If you're man in the middling it, you can do lots of things. You could send out a new profile that removes other profiles to downgrade security requirements. You might be able to do a multi-stage installation of malware, send out a web clip and a provisioning profile, convince somebody using social engineering methods to tap on that web clip. You call them up and you say, hey, I'm corporate, you see this thing that we just installed. And because they know their device is controlled, they know corporate has the ability to put on programs, they're probably going to trust that you really are calling from corporate. And I think rightfully so, to a certain extent. So they're going to tap it and boom, now you've got it. Of course, with the new install application command, they can bypass an awful lot of that and they just get a little hey, you want to install this app? Yeah, sure. It's corporate, damn it, okay. You can also do denial of service. The erase device command has no authentication on it. So if you're man in the middling and you're sitting at Starbucks and you see somebody's, you're watching the traffic goes by and you see something going to mdm.bigcorp.com and you're able to intercept that, you can just send a erase passcode command the next time it reaches out. If you can man in the middle an entire corporation, like if you hack in their DNS server and point mdm.bigcorp.com to your server, and if every Monday morning at 8, the server sends out, hey, show me your device information to all the iPods in the company, they're all going to immediately get that push notification and talk to the server, which is you because you've changed the DNS, and you're going to wipe out the device. So you can wipe out the whole enterprise if you really wanted to, I think. I haven't tried this. I wouldn't recommend trying that. That said, there are some good findings. You can't install a profile on a locked device. You can't read installed profile details. You can get information about that, sort of high-level metadata, but you can't actually read, for example, a certificate off the profile. The unlock token that we use to clear a passcode won't work for desktop synchronization, nor vice versa. You can't make a locked device resend an unlocked token. But that's not the whole story. I really only have 8 minutes, damn it. You can't install a profile on a locked device, but you can install when the device is unlocked. Turns out if you find the original MDM profile, which I mentioned before was a concern, and you reinstall that, it will re-enroll in MDM, which causes a new unlock token to be sent. So I think you can have an evil mate attack, which, if you remember, that's a way you can get into past full disk encryption. You get the device to talk to your server, get a copy of the MDM profile, force that installed on the server, on your new device, you get the new unlock token. Now you can send in a clear passcode, you pick up the device, slide the thing, and you're in. The man in the middle part, I apologize again, I'm going fast now because we're running out of time. The man in the middle part, you use standard man in the middle techniques, Wi-Fi trickery, etc. Or since you actually have physical access to the device, you've broken into the hotel room, you might be able to get on the device and do some things, Nancy host, install certificates, etc. To get the actual device, to get into it, you can use a DFU tethered boot mode. There's a way to actually boot, install a special bootloader, which will let you get into the device that's tethered on it, install SSH, mount the file system, get its stuff. You can actually modify the file system. You find where the MDM profile is stored, pull it out. You might also be able to get it from a legitimate server, and I'll describe that after I do a little demo here. Push out the profile. I've shown you this bit already, the MDM outstanding activities.p list. It's just a status idle message that gets stored in the file system. As soon as the MDM daemon sees this, it says, oh, hey, I have something to do, reaches out. So it's a way to force the device to pull the MDM server. You've got the device locked, you put that thing on, or booted DFU, you put that thing in there, you power cycle it, it boots up, it sees that file, it reaches out the server says install profile, it's locked, it says not now. That's actually the response. Instead of status idle, it's status not now. But as soon as the user picks it up and unlocks it, it sees that file again, says, oh, I still have unfinished business, reaches out to your man-in-the-middle server. The server says install profile, installs it, and now it's enrolled in new MDM. It's silent when it does this. There's no notification to the user. So when you saw me enroll in MDM before, it popped up, warning, warning, this guy can do these things. None of those things show up when you send, 10 minutes, yes. None of those things show up when you send resend the original profile. So it re-enrolls to you, since those are man in the middle, they all come to you. Can't do anything with the APNS tokens because you don't have the right certificate. But that unlock token, that key bag, is what's nice. So now you've got it. You wait for another chance of the device. The guy locks it, drops down his bed, goes down to the hotel bar or whatever. You break in again. Again, you DFU boot. You force the poll. You reboot it. Only this time, the server sends the clear passcode command. Now you're holding a device that's unlocked. You can browse through everything. If they're dumb enough not to have encryption set on the backups, you can just hook it up to a computer and back up the entire thing, dupe the entire thing. But now there's no passcode. They'll know something happened. Well, there's a nice way around that too. You take the token update that it gave you and replay that to the real corporate MDM. So now the MDM server, the real one, has the current unlock token and push magic and all that. Then you set a bogus passcode and you walk away. Guy comes back, tries to unlock it, can't do it, tries a few times, finally calls up, says, I don't know, I must have really had a good time at the bar last night. They unlock it remotely. They forget this ever happened. Is this crazy? Yeah, it's kind of psychotic. Doing the DFU access is pretty difficult. Man-in-the-middle server, it's difficult, but it's not horrible. Executing commands are easy. For a very high-value target, though, this is certainly not unheard of. If you've got a high-level CEO of a major corporation and somebody wants to steal the contents of his laptop or of his iPod, certainly. I keep saying iPod, iPad. You can do it with iPods too, but there's probably not as much data on iPod touches. And certainly if you think of like what a foreign intelligence agency could do, you know, shaking down airline execs at the Paris Air Show or something like that. So yes, it is pretty crazy. Is it crazier than a normal evil maid? Maybe a little bit, maybe not by much. But nothing quite as crazy as trying to demo this in the last 5 minutes of a talk at Shmoocon. So we're going to come here. I'm going to kill my server, which is gone. See, cannot connect to server, so my server's gone. CD into evil. Let's see, while I was talking, I set a passcode. So let's see. You can see passcode. Cancel that because I don't want to trigger that bug. Okay, so now I'm in evil. I'm going to run my evil server, and I'm going to get on the box, and I'm going to tell it to poll. Again, that copy the outstanding activities plist. And there you see a bunch of stuff just threw by. It says, hi there, I've never seen you before. Here, re-enroll in MDM so I can steal your keys. Oh, you're still locked? We'll try to pwn you later. So now you're set up. You've done all this work. You've created your evil MDM server. You've installed it in the air vent or something like that in his hotel room, so it's still talking to you. He walks in after his meeting. He unlocks his device, and watch what happens on the device when I unlock it while at the same time stuff scrolls by here. So he types in his password, 1234. Anybody use that on their luggage? There's the screen. Nothing's happening there. And you see a bunch of stuff just happened. Nothing, no indication whatsoever on the iPad. But down here you should see, where is it? Now I have your keys. It's got it. So that device is pwned. He just doesn't know it yet. Then he locks it, goes off, does some stuff. You break in again. I mean, how secure are those little cards anyway? I think Major Malfunction did a talk on that a few years back. Break in, again, you set that thing to poll. It sends the message. The server sends the clear passcode, and now when I touch this thing, and I say slide to unlock, if we're lucky, comes up no passcode panel. So like I said, a little bit crazy, but when you compare that to other things we've read about, you know, booting off a stick or doing cold boot attacks or all kinds of things to get past full disk encryption, I mean, if we're calling the sky falling on those things, then certainly this is more reasonable. I think even more reasonable than evil maid is an evil lackey attack. Instead of a hotel, you think about the office. Instead of a maid, you think over the passed over deputy to the deputy of the special thing in charge of something else. Instead of the hotel bar, it's the office gym. Guy goes down every night to the office gym. You come in, you steal his little iPad, you do things. You have a much longer time frame to execute the attack in. As an employee of the same organization, you very likely have the same kind of device. So you actually have an opportunity to play with the server yourself, understand exactly how it works, understand, yeah, every morning at 9, it sends off a command that updates the iPad inventory. So you can time your attack around things like that. With patience, you could probably even execute this entire attack without that crazy psychotic DFU mode by simply knowing the pattern of the MDM server. If you can realize that you can get an exact copy of the enrollment profile from the server, then you don't need to break into the device to get it. If you do all that, then you just basically set up your device, wait for the server to pull it through push notification, then it talks to you instead of the main server. Now you've got it, and you can do it this way as well. Still long, slow, not necessarily easy, but certainly I think very possible. How do you fix that? Better use of SSL. It'd be nice if you could pin the connection for the server, so whenever it talks back to the server, if it doesn't have a certain that matches what was there when it enrolled, it'll refuse a connection. It doesn't do that. Would also be nice if there was a user acknowledgement when you try to re-enroll in MDM, so it popped up a little warning saying, oh my God, we're re-enrolling. The user is still going to say okay, but at least they will know something weird happened, maybe. But that's not all. Remember that I said you can't install a profile to a locked device? Turns out that's not entirely true either. Both these things are things I stumbled upon, by the way. This one I stumbled upon last fall. Let's talk real fast about key bags. Key bags, literally a container full of encryption keys. It's used on the device to encrypt different data according to different protection classes, data and keychain entries and so on and so forth. When you lock it, the key bag that's in memory gets deleted, thrown away, gone. Those keys do not exist in memory, therefore it can't access the protected data because it can't decrypt it. That's how it locks. It's a very strong method. When you unlock it, it finds an encrypted copy of the key bag, uses data from your passcode to decrypt that bag, loads into memory. So that's how the keys get passed back and forth. The bug that I found is when MDM sends the clear passcode command and it loads that key bag into memory, it doesn't set a flag, a key bag and memory flag. I'm inferring that. I don't know that. That just seems to be the only logical explanation for what's happening. The user, so you send a clear passcode command, it's cleared, user sets a new passcode and locks it. The device appears to be locked, but because that flag was never set, the device never clears the key bag. It doesn't realize there's a key bag in memory, so when you lock it, it doesn't do anything with it. So the key bag remains in memory, so though it's physically locked at the screen level, at the data level it's really not. The protected data is not actually protected at this point. Appears locked to the user, but it will still process those privileged commands. It can re-enroll in MDM, you can send profiles to it. If it's jailbroken, you can log into it and read the protected data files. If it's not encrypted, if they don't use encrypted backups, again, you can take that, plug it into a new desktop, and just download the entire device. This obviously will not survive a second lock, so if the user immediately unlocks it and locks it again, then the flag would have been properly set, would have been properly deleted when they lock it, etc. The bug is reasonably repeatable. It works 80–90% of the time. I haven't quite figured out why it doesn't work the times it doesn't work, but it seems to work most of the time. So what? What is this good for? I couldn't think of anything at all. I mean, I sat for hours staring at an empty blank wall thinking about what could I do with this? But the implications behind it I think are really interesting because you expect that when you lock this device, you expect those keys to be thrown away. Apple's kind of built up this, that's how we expect it to work, and we've come to trust that. And this seems to be a hole in that armor. Specifically, I do wonder what the mechanism for this bug is. If it's just a flag, can that flag be triggered in user land? Can you have an app periodically trigger that bug? So maybe they download a piece of malware. Every time you unlock the device, the app comes to the foreground, changes that flag and goes away, so that maybe somebody can then get data off of it. I'm not sure. There might be some things there. Really, I'm just very curious to see what smarter people on iOS can figure out with this, because I find it intriguing. So it's a new bug. So to sum up, I said the whole reason I did this was because people ask us how secure is MDM. And my answer to that is it's really not that bad. There are definitely some limitations. There are obviously some holes, but there are no serious conceptual flaws. The way that it works makes sense. I think the issues that I found really all center around the man in the middle. Those are reasonably easy to fix. The protocol is pretty straightforward. It's documented, sort of, kind of now. Obviously, don't take this documentation and build a commercial offering out of it. Go to Apple and pay them the money and get the real spec. But hopefully this serves as a catalyst for research. Hopefully you can download the code, play with it, experiment with it. By the way, if you are experimenting with it, it's first in wins. So if you enroll your device in my server and your coworker enrolls his device in the server and you send an erase password to your erase device to your device, it's going to go to his device instead and wipe out his device. So, be careful with that. Some stuff I used doing all this research, mostly a lot of the good Apple stuff is push notifications, libraries, white paper slides and all that are on GitHub. under GitHub.com, Intrepidus Group IMDM tools, and that's it. And I will go over to the IG booth after this is done, and I'll be hanging around there for the next hour if anybody has any questions. Thank you.
What kind of interface layout?